I'm Marcia Villalba, and today we are going to talk about using AI and serverless to automate video production. But I will not be only talking about video production. I will be talking about other things as well with AI and serverless. We have quite a lot of demos ahead of us. But let's go back 1 year ago. I'm a developer. I've been coding for 20 years, even if I look very young. I started very early. And I never thought in my career that I will be like unnecessary or I will need to open a bakery. But last year, when the generative AI whole thing started to explode, and articles like these starting to appear in my feed, and these are the nice ones, they were ones that basically said that developers will not exist anymore, I started to get worried. I don't know about you. And I started to chat with my colleagues, with my friends in the industry, and trying to figure out what kind of skills do we need as developers in order to not be replaced by an AI. Because at the end of the day, now we know 1 year went forward that there's still a lot of work for us, but there's still many skills that we need to learn. So I kind of grouped the skills into two important categories. The first one is developer productivity tools. So that's something that since the prehistoric times when our ancestors started to code, we have been improving those developer productivity tools, like the programming languages. We started with machine code. Now we have very abstracted languages that makes our life easy. We have libraries that help us. We had good IDEs that help us. And also, since last year, well, this year, for general availability, we have Code Whisperer, that is an AI coding companion. I got early access to this service. And I was a little bit like, well, how it will help me? I'm such an expert coder. But it was truly dramatic for me, the help that it provided. I'm the type of developer that I code, I'm in the flow, everything is good, so fast, so good, until I don't know the answer. I get stuck, and then I go to the browser and I start searching how to use this library. And maybe I find the solution right away. Most of the times, you don't find the exact solution for your problem. So you try things out, you get a little bit frustrated, then you end up in Twitter and YouTube watching kittens jumping and breaking things in the houses. And 2 hours later, you come to your code without a solution. And the cool thing when I started using Code Whisperer in my IDE is that whenever I get stuck, this companion kind of realized that I needed some help and started suggesting me things. And usually the things that it suggested were pretty good and didn't let me go out of the IDE and help me to finish my task and get unstuck. So in this way, I became way more productive, even if I've been coding for over 20 years. So this tool is something that if you can, you should definitely try it out. Also, now, if you're a Mac user, we have Code Whisperer for the terminal. I don't know if you are using the AWS CLI a lot. I use it a lot, but I usually use 3 or 4 commands. Whenever I need to use something else, I need to go to the documentation and read it and check how to use those parameters. Now, with the Code Whisperer for the terminal, it just suggests everything on there, and I don't need to start going out from the terminal. So these tools really, really help out and improve the developer productivity. The second category of tools is the ones that are core for developers, that is building applications. Now, our stakeholders want to build applications with AI in mind, want to build applications that can recognize things in images, understand and manipulate languages, create text, images, music, whatever you can imagine, make recommendations, answer questions in natural language, create avatars, synthetic voices, and whatever you can imagine. They're asking for that. But I'm a developer. I love building applications. I don't want to become a data scientist. I don't want to start building models. And maybe neither of you. You just want to use tools that are available for you to start building these applications. The good news is that the AI landscape is pretty rich. And as developers, we can basically use those things, services, APIs that are in the internet, in the cloud, provided by different startups, right away in our application. If you're AWS users, you might have already used some of our core AI services, like Transcribe, that transcribes audio into text, Translate, that translates from one language to another, Recognition, that recognizes things in images and videos, poly that can read things out loud, comprehend that can detect sentiments and entities in text, extract that can recognize text from images, and we have way more services in our portfolio. Some of you are lucky enough that you work in organizations where you have a data scientist team that can provide you models and endpoints from those specific models that you need for solving your problem. So they might use SageMaker to build those models, or even they might use SageMaker Jumpstart to deploy open source models and start using them, and they give you an endpoint. Or maybe you already are using Bedrock with the foundational models, and your team is already kind of making sure that those models are enriched with your data. And finally, there is a broad ecosystem of third-party AI services. Many startups are providing APIs, so you don't need to build them, and you can start embracing AI in your application. At the end, as a developer, everything is an endpoint. So we should not be afraid to start embracing AI, because we have been calling endpoints since the beginning of our careers. That's how we started building. Let's call a ticketing endpoint. Let's call a booking service. Let's call this registration thing. Let's use this API for this and that. So now we have AI endpoints. Some of these endpoints are a little tricky because they require some kind of engineering on the requests that we are doing to these APIs. For example, if you're using generative AI, you usually need to craft a prompt. And this takes a little bit of fiddling around, figuring out what is the right prompt to get the right results. And because we are talking about generative AI, sometimes we need to play a little bit with these prompts in order to get something that is consistent enough. And also, if we want to use these results in our application, we might need them in JSON with some particular attributes that can help us out. So prompt engineering is something that you might want to learn. Also, when we talk about prompts, sometimes we need to, one thing that is called prompt chaining or prompt splitting. We need to grab a prompt, split it into many ones, run all these little prompts in parallel, merge the results, or then run one prompt over a little piece, and then feed that result into the next prompt, and chain these prompts together to get a result. And when we are working with all these things, basically what we need to do is to orchestrate and choreograph the calling of these endpoints to either do the prompt chaining or to call the different AI services that we want to use. So this talk, I will not be talking about how to call endpoints. You are all developers. You should know how to do that. That's something we have been doing since forever. I'm not an expert on prompt engineer, so I will not help you with that. But I hope you leave this session feeling very, very confident about how you can orchestrate and choreograph your AI services to build really cool applications. At the end of the session, that's what you should learn. How you can embrace so many AWS services and patterns from architecture to help you out. So my name is Marcia Villalba. I'm a developer advocate in the serverless team. I've been doing serverless since its early beginnings, 2016. And I'm the host of a YouTube channel called Fubar Serverless. So a lot of the links I will leave you after this presentation will be hands-on tutorials on how to do everything. So I will not show you how to deploy, how to build. That's all in videos later. From when you have time, you can sit down and get the code for everything. If you have any questions, you want to learn more, you want to deep dive, reach out to me on socials. So this presentation is breaking into 3 demos. The first demo is a bedtime story application. Doesn't have anything to do with video, but I really like this simplicity of the solution. This is a solution that my colleague Dave Boyne built. He has 2 little kids, and I don't know if you have little kids, I have one, and she always wants exactly the same, and Dave had the same problem. Every night we go to sleep, she wants to read exactly the same book. And as a parent, it's very boring. You know it by heart, and it's always the worst book. My kid likes to read the history of farts and burps. Very educational book, but I'm sick of it. So they've created this app because he has exactly the same problem. Every day at 7 o'clock, a new story is generated based on characters that the kids like and scenes that the kid likes, and Dave receives an email with the story so it can be read out loud. This story is generated with AI. It also has an image that has been generated by AI. And if Dave is tired, it also has a play button that will read out loud the story. So great. This is not the story that Dave will read to his kids. This is a story generated with my colleagues, Dave, Eric, and James, that are part from my team, where we are pair programming. I hope Dave's kids still don't pair programming. They're quite young. But the cool thing of this is the architecture. That's why I brought this to you. Because this is an architecture that demonstrates event-driven in its finest aspects for AI. You can see that it's very linear. It goes from scheduler to an email notification. And all this architecture is being driven through is events. Something is changing in the system constantly. And that is propagated forward and activating different services to act. That's event-driven architectures in a nutshell. We have somebody that produces an event goes to some kind of broker, and then somebody consumes the event. The producer, the broker, they don't know each other. The producer and the consumer don't know each other. The broker is in the middle. We call this choreography of events, because instead of having an ordering service that will tell, hey, notification service, customer has made an order, now send an email, now we have an ordering service that will say, customer has made an order to the broker, and whichever service is interested on that will react and say, oh, the notification, a new order has been created, I need to send an email. The marketing will say, hey, a new order has been created, I will send some spam, and things like that. So this is why it's choreography. The services are listening and dancing to the sound of events. So let's go back to the architecture and analyze it bit by bit, how this happens. So this is the first bit of the architecture. We have the scheduler, and we have a Lambda function. The producer of the event is time, 7 o'clock every day. The broker is the scheduler, and the consumer is the Lambda function. The Lambda function will grab the characters, the scenes, will call bedrock, and generate a new story that will be stored in the story table. I don't know if you're familiar with Scheduler. This is a service we announced last year. And it's how you can schedule tasks in AWS. You can schedule millions of tasks in your AWS account. You can schedule one-time tasks, like today at 3 o'clock, or you can schedule recurrent tasks every 5 minutes, or every day at 3 o'clock, or every Monday at 2 o'clock. And you can even add time zones to it. So it's not the same, my start of the workday in Finland with my time zone, than the start of the day that you are here in Vegas. So these type of things you can configure, and it's really, really cool. But the coolest part, in my opinion, is that you can reach over 200 AWS services. So it's not only triggering a Lambda function, but you can start your containers task, or you can start sending an email, or you can start a glue shop, or whatever you need. So let's look at an example with Scheduler that nothing has to do with AI, but I think this is an example that most of you might be familiar with. That is canceling a subscription. I'm the type of person that I will watch one season of something, I will register to the streaming service, and I will cancel it right away, because I have already paid hundreds of euros in streaming services that I never watch. So I learned my lesson. So I will go to the streaming service, cancel the subscription, and I will have 1 month of a subscription valid, even if it's canceled. So if this service was using Scheduler, what will happen is the Lambda function will create a new schedule that says, hey, in 1 month, remove this person from the paying customer list. Month comes, that schedule gets triggered, and exactly that happens. This is a very common problem that many organizations have, and before they have to record to very complex solutions in order to address it. Now with Scheduler, it's as simple as it comes. So now we have our stories in our story table. That's a static table. Still, it's a DynamoDB table, but it's static. The data is there static. So we need to capture the change that happens in that database. For that, we are using the pattern called change data capture that allow us to capture events and things that happens into a database. Because we are using Dynamo, we can enable event streams, and that every time there is a change in our database, will trigger an event. So now we have events flowing in our system. The thing is that we want that events to go to an event bus, so we can manipulate that event. The problem is that DynamoDB events and event bus events don't talk to each other. Integration problems, how you have those? But the cool thing is that we have a new integration service called Pipes that will solve that point-to-point messaging, that integration between two different event-producing and event-consumer systems. So now you can connect DynamoDB to EventBridge, super simple. Or you can connect Kafka to Kinesis, or Kinesis to EventBridge, or whatever you have in your mind. And the cool thing is that whenever you are connecting these consumers and producers together, you can filter and transform the events. So my favorite example here is when we connect one Kinesis to another. Because usually when these data streams come in from our clients, the events are all weird because the client's SDK might have changed, they might not be standardized, we might have a lot of noise, we might have analytic events, we might have backend events, we have all kinds of events mixed together, and then I can apply a pipe and filter out the events I want, I can transform them all to be standard and looking perfect, and then send it to another Kinesis data stream that those events from the second Kinesis data stream will be processed by my downstream services. And my downstream services will need to do less work on the filtering and the enhancing of the events already. So now we have our events in the event bus. And what we want to do is to fan out these events to different places. We want to send the notification. We want to generate an image using stable diffusion with Bedrock. And we want to generate an audio using Poly. So to find out events, the best way to do it with EventBridge is using an event bus. An event bus allows us to get events from different event sources, like AWS services, S3. We'll see it in later demo how we can use S3 as an event source. Custom applications like the one you have here that is sending a story, a new story has been created, or different SaaS applications can send events into different event buses. So event buses are like little highways where those events are navigating. So if an event is in a default event bus, it cannot be in a custom event bus. So you need to choose where your events are going. And inside those event buses, we have rules. And those rules will be the ones directing the events into different places. So we will have a rule that says, all the events are coming from S3, this particular bucket. When there is a new file created, will trigger this Lambda function. Or all these events from when a new story is created in Dynamo will go to this SNS topic for a message to be sent. And then we have targets. For EventBridge, we have over 20 different targets in AWS and API destinations that allows you to send events to third-party services. So you can connect, if you are doing, I don't know, a fulfillment service and you're using a third-party delivery service, you can add that as an event and send them an event. Hey, here's a new order. You might need to fulfill that. So how rules work? They're very simple. An event source sends them into a bus, and then the event will get matched against all the rules that you have defined in the bus. The event can match non-rule, one rule, two rules, all rules, whatever. And when the rules match, then the event will be forwarded and fan out to all the different targets. So it can be forwarded to no one, so that event didn't happen, nobody listened to it. Or it can be forwarded to so many different places, it can be fan out. And this is how we solve the problem. So now we have a full architecture, all driven by events, and it's generating the story, it's generating the email, it's creating the image, and it's doing the voiceover. So this is the first example I want to show you. Now I want to jump into the core of this talk, that is automating video production. Now, this is a problem that happened to me last year. And when I started building this, I never thought I would be giving a talk on it. Because it's a problem I have every day. I'm a content creator, my team is a content creator, and we have a lot of content in English. But I also have an amazing community in Spanish that needs good content and deserves good content. But I cannot clone myself to create good quality content in Spanish all the time. So I was looking Discovery Channel in Latin America, and I saw these videos that we get that are dub. And they're obviously dub. And I was thinking, can I do the same for my content? Can I dub it? Can I use AI to do that? And that's how the inspiration came to build this demo. But it's not a demo, I actually use it every day for my content. I upload a video, it gets dubbed automatically, and I get an email. Over the course of my development, I realized that AI is not that smart. And I need to do some validations in the process in order to make sure that the quality, the results of these videos are really good. because the audience deserves good quality. So even though everything is automated, I still need manual inputs in the process to make sure that the results are good. So I will show you now the demo, and then we will go into how I build it. So this is the first step. Everything happens from the CLI. I'm not a front-end developer. So we will upload a video in English to S3, to a bucket. That will take a little while. It's a short video for the sake of the demo. And this will trigger a new state machine. Don't worry if you don't know what it is. We will look at it in a second. This, what we'll do, we'll transcribe the video, store the transcription in S3, and send me an email when that's ready. So basically, in my everyday flow, I don't need to go to the AWS console. I'm showing you the console so you don't look at my email appearing. But this is something just for the demo's sake. I get an email, and I get the transcription. This is very important. I need to validate this transcription and make sure that the transcription is correctly. This is where the human component comes in place. So I make sure that the transcription is corrected, and then I upload it to S3 again. Usually there are a few changes that need to be done there, but those are very critical to the end result. Then a new state machine runs, and that will translate the text, in this case from English to Spanish. It's very fast, and I get a notification. Then I can validate this again. Usually the validation here is minimal because the transcription is so good that the translation tends to be very good quality. But there is some words I like to keep in English because it's a technical video and it sounds better in English. I upload the validated translation, and now two state machines in parallel will start running. The first one, it will generate a lot of assets for me, being lazy, to upload these videos to YouTube. The second will dub the video. So let's look at the first one. It will use generate AI. It will generate a JSON that looks very bad because it's me doing this in Python. We'll talk about that later. And it will generate a description that I can copy into YouTube, 5 titles that I can use so I can pick which one is the best, and some tags that I can tag the video with. And this helps me a lot with my process because my thumbnails are automated already through another place. Now I have my description, I have my titles, I have my video. I can just upload these videos to YouTube in a few minutes. The second state machine is dubbing the video. It will use Poly to dub the video, basically to read that translation out loud. And then it will use a Lambda layer to stitch that new audio file into the old video file. And I will get an email. And this is the final result. We will see it when I click the link on the email. And you can hear Eric Johnson speaking in Spanish. So,
hola y bienvenidos a Serverless 101. Me llamo Eric Johnson y soy un developer advocate para AWS Serverless. Serverless 101 es una serie de videos que le ayudará.
So let's go back to the beginning of when everything started. I said that I was not thinking about delivering this as a content piece. I wanted to just solve the problem. I also was not aware that I will need to do manual validation or I wanted to do generative AI. I just wanted to dub videos. I'm a serverless developer, so the first thing I did is like, let's make a big Lambda function and solve there everything. So I grab a Lambda function, I start writing, please transcribe, the API to translate, then call Poly, and then use my magic code to stitch the Poly audio with the original video and give me a result. And it worked. For my test videos of 1 minute, it was perfect. The moment I upload a longer video, it exploded. Because transcribe, the dubbing, Poly, usually those tasks depend on the length of the video. And Lambda only can run for 15 minutes. So I needed to find a way to find a long-running process to solve that. Also, whenever I wanted to test something, I needed to run the whole thing over and over again. And my code was full of console log parameters, console log results, to see what all these APIs were returning all the time. So I throw this implementation to the trash, and I thought, like, how I can build this again. What if I have one Lambda function that does the transcription, one that does the translation, one that does Poly, one that does the dubbing, and I connect them. When one finishes, it calls the other ones asynchronously, and that will solve the problem. I didn't like that. We talk a lot about events, so here is where my internal developer advocate starts throwing me and say, Marcia, you talk about that events, don't do that, don't do that. So I was like, well, instead of using function chaining, I will call events. And this is something I implemented. I make a lot of little functions that were grabbing the file from S3, doing the transcription, putting the file in S3, and sending me an email. Now I'm already starting to add the validation to the process because I realized that it was important. An event, then a notification will be sent, I will upload the validated transcription, another Lambda function will run. Now it will do the translation, upload to S3, send me an email, I will validate the translation, and then I will have couple of Lambda functions, as you saw, but instead of using state machines with Lambda functions. So I was building this little Lambda list. And again, my internal developer advocate was pulling my hair, and this is wrong. We tell to customers that they should do Lambda functions that do one thing only, and these are a little hard to test because they basically are calling an API, and I need to console log all the time to see what is going on. Nah, I need to find a better way. Because at the end of the day, what I'm doing here in these functions, in these particular functions, is task coordination. I'm using the function to sequence task, to retry task. By the time I was developing this, there was no Bedrock, so I was using OpenAI. And OpenAI was sometimes not very responsive, and I needed to retry, and I needed to catch those errors and do something with it. Sometimes I want to do a map over an array and apply a same function, or I wanted to do a choice, a switch, or I wanted to run tasks in parallel. At the end of the day, I was building an orchestration pattern. I was building a little controller that was managing state, and it was sending it to the different endpoints, to the different APIs. And I realized that what I really needed was a state machine. A state machine is a collection of computational steps, discrete computational steps, things that do one thing and one thing only. We have one starting state, an active state. Every state has an input, gets an output, does something, very easy to replace, components that are very decoupled. And these transitions between states are based on the outputs and rules that I define. So our brain, naturally, as developers, as humans, go to build state machines because these are things that we can build very simple in our flow, like these flows of actions. But if you're building state machines in AWS, I will recommend you to try step functions. That is our state machine managed service. Basically, you can connect, and you can do it visually, or you can do it as code. I will give you the code for everything. You can throw different boxes to call APIs internally from AWS, or HTTP endpoints from your different services. You can add operations like flows, choices, parallelization, try, catch, retries, error handling. And the good thing if you do it in the Visual Studio Code, in the Visual Studio from step functions, is that you can get the whole definition of the state machine and build it as visually, but also keep it as code in your GitHub repo so you can iterate on that. Step functions integrates with over 220 different AWS services. And it integrates, starting this week, with HTTP endpoints. So basically, you can integrate anywhere nowadays. So now we can break this little Lambda list into a state machine that solves exactly the same problem. And I can reutilize some components, like my signing URL function that is signing an S3 object, so I can get that in my email. I can also reutilize my topic. I can build these state machines, and you will see how similar all the state machines look, because at the end of the day, that's the simplicity. We want to have simple patterns that can be replicated over and over. And by the end of this exercise, I end up with 3 Lambda functions that do very simple things, but very critical to my solution, very specific, and I could not replace them with anything else. Well, we'll see that we can replace now one. But first is the dubbing of the video. That's using a Lambda layer and using a library called FFmpeg. Then the get sign URL that does some magic and gives me a sign URL. And then the calling Bedrock with the generate video description that will do all this JSON with all this code. And then everything else can be transformed from code to workflow. I can grab code that I had in my Lambda function, and transform it into something, into an API call from my workflow. And the cool thing is that I can add all the retries and the error handling in the state machine. My favorite part is that now I don't need to add console logs everywhere, because whenever you're running a state machine, automatically you will see the input and the output of that API call. So you will know exactly what was sent and what was returned. You can see the errors, you can deep dive in every error, you can understand how long everything took, and you can really improve your application by working from the state machines. And if you want to avoid functions, again, one really cool feature that step functions have is intrinsic functions that allows you to do basic data manipulations on JSON, arrays, strings, math operations, encoding, decoding, and many, many other things. So now if you need to generate an identifier for some data that you want to store in Dynamo, you don't need to call Lambda functions to generate that identifier. You can do it from your state machine code. So it looks something like this. I'm used these intrinsic functions into many places. So you can see there in the parameter attribute, I'm building a new URI. And I'm formatting that URI with two dynamic parameters, the region and the payload. And it's as simple as that. I just format that, and I will get the right URI. And I can do more complex things. I can nest up to 10 intrinsic functions together to build very, very interesting results. So here you can see in the command that I'm building an AWS CLI command, so I can copy-paste it from my email into my CLI. I'm that level of lazy. That will basically grab an URI, split it by the backslash, and then get the third item in that result, and paste it inside my AWS CLI command. So that command is perfectly built. And these are 3 levels down, but you can go up to 10 levels. So let's look at the architecture of this solution now. And you will see the simplicity that it has. I like simple things. We have a state machine, the first one, that gets triggered when an event happens. Put something in S3, sends me an email. This is the first state machine. It's called transcribe. Transcribe is an asynchronous call. So we here need to do a little waiting for the asynchronicity to happen. So we will start the transcription job, and then ask if the transcription job is done. Here, it doesn't matter how long the video is, because the state machines can run up for 1 year. And I'm not planning to record 1 year of video length. So we are fine here. Then it transcribes, and it puts the file in S3. And again, it does exactly what we were doing before. Sign in the URL, sends me an email. Second state machine, translation, works exactly the same. Triggers by an event, puts something in S3, sends me an email. The state machine looks very simple, but because translate is a synchronous call for small amount of text, I can just basically send and receive the results right away, store it in S3, and sign the URL and send me an email. You are seeing the drill here. Another state machine, dubbing the video, gets triggered with an event in S3, puts something in S3, sends me an email. Now we are using poly. Poly is another asynchronous call. We are calling poly, waiting for poly to execute. Again, this is independent from the function, so it can last up to 1 year. So poly can take its time to process and create that audio file. When the audio file is ready, we'll send it and start invoking this Lambda function that will stitch that new audio file in Spanish with the old video. And it will send me an email. Fourth step functions. Again, we are generating the results with generative AI, the description, titles, and tags. A new event calls the state machines, puts something in S3, sends me an email. Now, we are just calling a Lambda function to do that. And now you might be wondering, why to have multiple state machines instead of a big one? And I wonder this question for my whole, I was in Alicante when I was thinking about this. I'm that crazy. I was in the beach, and I was like, why have so many state machines? What is the reason that my developer advocate heart make me build this that way? And I will explain you my thought process. This is the result. All state machines are invoked with an event. You saw the simplicity of that. Let me show you how you can write the code for invoking a state machine with an event. I talk about event-rich, that you can trigger things with rules from AWS services. So here we are triggering the state machine from a rule when a new object is created in a specific bucket. This is all the code I need to trigger the state machines. The only thing that will change for each state machine is the name of the bucket. Then I can copy-paste it. I mentioned I'm lazy. Let's look now what happens if I will have one big state machine. For the simplicity of this demo, I'm making each state machine a nested state machine inside a big one. So there is not a lot of mess. This big state machine gets triggered with an event every time we upload the original video. For solving this problem, you need to learn a pattern called the call me maybe pattern. My colleague Ben Smith named it like that, that will pause a workflow for up to 1 year until a task token is returned. So we can have a task that is run with the wait for task token. And this will pause the state machine for 1 year until the task token is returned, generate a task token that later we can restart the state machine if we return this task token back. So this is a pattern you need to know in order to see how we can have one big state machine. So now let's go to a little architectural diagram. So here, for simplicity, I have only 2 steps in my process, the transcribe and the translate. Because in the middle, there is a manual approval process, and I want to show you how the flow will be. So we have the new video in English uploaded. That will trigger the state machine. Until there, we are the same. We start the transcription, store the thing in S3, sends the email. Now we say, wait for task token in this step, and we will get a task token, and we will store it in Dynamo. Now the state machine pauses. Marcia comes in, validates the transcription later on, and uploads that file to S3. That triggers a rule that will grab a Lambda function that fetches the task token from Dynamo and restart the state machine and do the translation. And now we need to do exactly the same, all this shebang, for the translation to the next step. And you can see here that there is a lot of things happening. And simplicity is always the king. We want to go as simple as possible in order to minimize problems, because now, if I want to add a new step, I need to build all these things at the side of my state machine that I need to test, that I need to make sure that everything is working, and it's hard. And we don't want to have hard things because we need to maintain them. Maintaining, as Bernard was saying today, building the code is this, maintaining and operating is this. So we want to keep things as simple as possible. Adding a new step in my simplify process is as simple as having a state machine reacting to an existing event. So this is the simplicity that we want. We want to not create a lot of cognitive load in our developers. So here you have seen how orchestration and choreography work together, how we can use events to connect microservices of tasks together, how we can use workflows to coordinate tasks together, how we can do workflows to strict coordination. That's something we need in general when we want to do things in certain order, and how simple it is to add new functionality with events. Now let's go to the generative AI aspect of this talk. I mentioned a million times during this presentation Bedrock, and you might be all familiar with it because nobody looked at me like what she's talking about, so that's good. But Bedrock for me was a revelation because, again, I'm not a machine learning expert. I'm a developer. So for me, it opened the door to build generative AI applications through an API. I got access, and this slide is already outdated because we had announced so many things. I got access to a lot of foundational models just through an API. From the Amazon ones to the ones that are built by our partners and startups, and I could pick the right one to solve my problem. As Dave was using Stable Diffusion to generate the image, and I was using Jurassic 2 to create all my assets in my videos and things like that. So you can pick the right model for the right problem. And if you have a team that can fine-tune that model and can do that, it's so simple as pointing an S3 bucket to your data and get Bedrock on the work to fine-tune the data and start giving results that are specific for your use case. So let's go to our state machine. I show you that we have a state machine that uses a Lambda function. I'm sorry to tell you that this slide is already outdated because on Monday or Sunday, we released the connection from step functions to Bedrock. So now you don't need a Lambda function to do this anymore. This happens every reinvent. Half of my lights go out of date very fast. But that's good, because now you can just basically drop the Bedrock component, pointing to the model, and boom, you're ready to go. But I didn't want to remove this slide because there is also one interesting thing. This happened when I was building this Lambda function. So if you want to call Bedrock from Lambda, the only thing you need to do is to give permissions. So give permissions that are in the right action. So you can be specific and say, Bedrock invoke model, not like I'm doing here with a star. Or you can give permissions to the right resource, and the resource will be the right model that you're using. So you can give permissions to your function on the right API and in the right model. And then you can write the handler of this function. I will tell you a secret, and it will not be a secret anymore because we are recorded, so it will not stay between us. This function was written by Code Whisperer. When Bedrock was announced, it was announced for a few weeks, or I would say days, only with Python. I'm a Node developer. And I was like, I need to try this. I need to change my demo right away. So I went to Code Whisperer, and I told, hey, can you help me? I need to write a JSON and receive something and write a function. I start giving prompts. And basically, Code Whisperer helped me to build this thing without me not knowing Python. And I was blown away. So I use it a lot. So the first bit here is the prompt. The prompt is something I iterated a little bit and is grabbing things from the event, from the function that is receiving. Basically, it's receiving the transcription, the translated file, and then it's generating the assets. So the prompt is there. Then we have these 4 parameters. And if you're a developer like me, you will be looking at those 4 parameters, and it's like, what that means? And I will tell you a thing, Bedrock is great, because you can go to the Bedrock console, to the playground, and you can write your prompt, you can fine-tune it there, so you don't need to go and iterate a million times. You can change your inference configuration, and there it will tell you more information on each of the configurations that are there. For example, an important one for me is the maximum completion length. That is the amount of tokens that this thing will return me. So if I have a very long file, I want to get a longer result, maybe. And then you can go and make sure that your call is right and select View API Request. And this will return you a JSON with the 4 parameters configured exactly as you need them. One thing is that every model has different configuration. So it's important to always check that the configuration that you have for one model is valid through the next one, because it will not be. So always check this API request. And that's how I created that. Then you call the model. In this case, we are using Bedrock invoke to invoke the model and get a response. We can also do, not from step functions, but if you are using Lambda, you can do response streaming. So it can stream back the response back into your client, so it can be more dynamic, the response. There is demos on the resources. And then you can get the response and send it back to the step machine in this case. If you want to see this in action, we have serverless video. Serverless video is a demo that my team built in order to live stream video. Now we are live streaming from reInvent. It's totally built with serverless architectures. So if you open it, you will see people broadcasting right now, and you can also watch the on-demand videos. There is a lot of generative AI going in serverless video. And it's a cool architecture built on plugins. So this is the architecture. And now that you learn about events, you are maybe a little bit more familiar with that core that is connecting our microservices. All the microservices are connected through events. And the cool part for this presentation is the plugins that are down there. We have a group of amazing solution architects, and we asked them to build plugins for this application. And all of them came with different solutions that they were reacting to different events that later we could integrate into our solution. So they built plugins mostly using AI. So the first plugin was that somebody transcribed the video on demand when it was processed. And you can see that the solution that they built is very simple, similar to the one that I have already implemented. The second plugin that somebody built was using Bedrock for generating the titles, the tags, and so on. Until nowadays, we have a list of plugins that is really long. So if you go to serverless video, you can click in any of the videos that are there to watch on demand, and you can click a button that says how this video was processed. There we explain you how we do it. And you will see a lot of state machines. For example, one really good use case for video processing. If you have a longer video, you cannot use a Lambda function because Lambda functions time 15 minutes in. So we use ECR. So if somebody decides to stream for 45 minutes or 1 hour, instead of processing the video with Lambda, we have a state machine that will decide, oh, this is a longer video. This needs to go with ECS. If it's a shorter video, it goes with Lambda. And it's the same container image, because that's the amazing things of these two things. They work very well together. And then, after the video is processed and converted into MP4, we can then apply all these plugins that the amazing solution architects build for us. So we will moderate the content using recognition. So if somebody's showing something inappropriate, violence, or nudity, or something that is not right, we will not allow this video to be played on demand. Luckily, our testers are quite nice and never happened that. Then we are transcribing those videos, because you saw the power of the transcription. With the transcription, with the text of the video, you can do so many things. Then we apply the titles. Then we generate tags. Then we do a leaderboard. And all of this happens inside a state machine. If you want to learn more, we have these builder sessions going on. I hope there is one today that will go more in details of Power Tools, Lambda for video streaming applications. So you can check it out. So let's wrap up. Don't panic. Everything is an endpoint. There's still a lot of work for us, and more than ever. You need to call these endpoints for your applications. That's what we have been doing forever. Use AI services. Embrace them. We always want to build our applications and let someone else do the other parts that is not our expertise, either our ML teams or AWS or startups that are dedicated to us. Embrace Bedrock, AI services. Orchestration is very useful to coordinate tasks, and this doesn't apply only to AI applications. But you learn today that to build an AI application that can do many things, you usually need to combine multiple services together, transform the data, and stitch them into the next service in order to get a result. Step Functions is a great service. Integrations with AWS services. Integrations with HTTP endpoints, so you can call your third parties and your startups. Support for asynchronous and manual validations. You can integrate also with the same pattern that I show you. You can integrate it with legacy systems or other systems outside AWS, not only with manual processes. Intrinsic functions to do simple data manipulations. Event-driven choreography is great to react to events in your environment. It's 7 o'clock, somebody upload a file, a new video is ready to be processed. Event Bridge is a great service to have in your toolkit. Schedulers is very good for reacting to time. Pipes, great to integrate different services together that are producing events and we use all the time. And buses that help us to find out and create rules to move those events forward. And as I promised, here are all the resources. You will find a deep dive on step functions, on Event Bridge. You will find the code for the applications that I show you today. You will find the launch announcements for all the things that I told you that we announced this week that are relevant for this. Everything is here. But if you're not a Node developer, you might think, oh, a lot of these things are based on Node. But don't worry. Check the theoretical part, and then jump to serverless land and find the solution, the pattern in your right infrastructure as code framework in the right language for you. So you like to do it in Terraform? In our 600 patterns, you will find the exact pattern that you're looking for. You want to build state machines with CDK? You want to do Event Bridge with Terraform, Pulumi, or whatever? Everything is there. So that's it for me. we have like 10 minutes, so I can take some questions, but I